All right. Hi, my name is Rody, and today we're going to be talking through how to build an ORM with Firestore and SQLite. Um, I put the link for the code in the description below if you want to go ahead and jump in and download it, but otherwise we'll go ahead and get started. So what do we want to do with this ORM, first of all? I have a README kind of going over the explanation of what I'm trying to solve, but let's just go ahead and lay out some things here. So we're going to be working with Firestore, and that's so we can get the benefits of sharding using a NoSQL database and great replication, offline support. But I want to combine it with a really awesome local SQLite. So local SQLite database. We want to have things like full text search, generated clients. So that could be GraphQL. This could also be a REST API. Or also we just want like a client SDK. So that sounds good, but what do we do next? Well, in generating this client, we need to have some type safety. And with NoSQL, typically it's really hard to update your schema over time. So that's where the client-side SDK comes in. We're going to need a schema and an admin UI to manage the schema updates as well as manage data. We can make it available just to our admins, but one thing that's different is this is deployed with your app and not hosted separately. And another thing we may want to generate is Firebase functions. So far it's looking pretty good. And we're about to jump into the code that I already have set up. But I just wanted to mention one thing, that this all kind of came out because I really like Pocketbase. It was a cool abstraction over SQLite, which I'm a huge fan of. And I was seeing what could we do to kind of push it further with Firebase, where we can get the benefits of this admin console of a type schema, and just like SQL, it can be optional on if you're enforcing that type, but to give you that really good client SDK. So just to show you like an example, here we have like a GraphQL endpoint that's coming actually from the thing that we're about to go over. And you can see we have like nested data, linked things across collections, and all this type safety is generated for you because we have the schema. Not only that, but something that's really cool in the Firebase functions is we can generate triggers for when a document is deleted and you're referencing that document in another collection. That seems like something we want to have automatic and not have to be done client side. So we have a mechanism for dealing with that. And we have a lot of cool features to go over today. And also going to show this. This is the README. This will just kind of show you a preview of what I'm talking about. We have our admin UI schemas. We want to be able to support multiple types of information: text, numbers, booleans, dates, arrays, maps, options, even file object. That would be like if you wanted to put it onto a bucket, and my favorite, which is document, which is a foreign key to another collection. So for example, like we have this given piece of JSON, we want to have a name and an age field. Well, this ultimately becomes a collection schema with two field types. And we can provide descriptions for helpful comments and whether it's required and other metadata, but trying to be as minimal as possible on defining this. Some bonus things that Firebase doesn't store for you out of the box that I'm making sure to is an ID field, a created and an update field, which are going to be used for caching. So we know when the document's been updated, when we need to fetch some more results. And so we can make really efficient update queries, as well as being able to, if in the future we want to do time to live, which is a cool new Firebase feature that they launched at the summit. And something else that I run into with my apps is it's really hard to make a schema that can be modified over time, because you could have multiple people using your app and they'd be having different versions of this app at any given time because maybe they haven't updated, but you're all pulling from the same database. And so with that, we need a way to be able to tell both the client and the SDK that there is a new field for a given type and that it can fall back to that previous field. So for example, if we wanted to make it display name instead of name, we'll keep a track of all the previous fields this is used in this field for this collection. And you'll see in the generated client SDK, we have a special method for retrieving a value and setting a value. And this is where it'll actually do that check to see if there's actually a new update available. Because since the schema is also stored in a collection, it'll be able to update the schema over time, since it's just a document, and we'll be able to make some really rich updates, because if the user's offline and they're accessing existing data, it's going to be from the cache and they don't need to check for that new field. But then as soon as they do things online, there could be data coming in this new format. Another thing is we'll have tombstones for deletion. And I talk about that here. Basically, if you want to delete something, you want to be able to help with all your clients that maybe have that offline and you want to sync it before you delete it. So we can just have a deleted field. And then after a certain period of time, we can start wiping that out. Maybe it's 30 days or whatever, but it gives it enough time for users to sync with that. So we're going to be generating classes, this SDK, Firebase functions, so we can define all the relationships, this GraphQL and REST API, which are both optional, by the way. Of course, the data migration, data import. I have some easy methods in the UI I'm about to show, the client SDK, and just trying to show that there's like this cohesive connection between all of this. Another thing that I had thought about that I think would be pretty cool is there's a package for Flutter called iCloud storage. So maybe when you're syncing since we have a SQLite local database, it actually is possible to sync that SQLite file across multiple clients. So if a user has an iPad, a phone, and maybe a MacBook, it can sync that database file across all of them, because we may have fields and tables in there that don't exist or ever need to exist on the server, such as like if they have a downloads table and it's just keeping track of all the file in the system of cache things, we can just sync that across multiple devices with those assets. Yep. And then one final thing, which kind of came up as I was building this, is I found out about Firebase bundles, which are an awesome way to put a bunch of things in a collection into a buffer, and we can dump that into storage and have a really awesome way to load a collection offline. So let's say you have a given collection that doesn't change a lot. In the video where they talk about it, it's like they're using Firestore, so maybe you have like a product collection. Well, we can actually like package those all up and provide it to our users as a single buffer. And so that counts as one read, since we're doing all those at the same time. Of course, reads on the collection, but it'll only be a single time when you're generating that buffer. And then for everyone else, they can read from the cache. This makes it really great for immutable data or data that only is changed by a single source. So I think that pretty much covers the README. Let's go ahead and dive into the UI that I have so far. So here we have just a simple Flutter web application, and we have some fields in here. Just want to show you that full text search works. We can search across all the documents. It's going to return all from the SQLite instance. This isn't having to query the server at all. One thing you see up here is this admin console. This only shows up in debug mode, which you'll see in the example. But you could also deploy this to production and check the user's auth to see if they could be an admin before showing this button or hiding it. A bunch of different ways to do auth guarding, but let's go ahead and jump in. So here we're given, this is just pretty bare bones, but I just wanted to show this whole concept working together. We have a collections root level with here's a list of collections in our schema. I had some easy copy and paste from clipboard since I didn't want to implement file input and download for right now. We have the schemas themselves, and we can go in and edit them. So here we see this is a table view with the data that's currently in Firestore, and we can also go over to our Firestore emulator and see the same data. Let's go ahead and add a new artist. So when we add it, it'll get added to the artist record. And if we go into here, we will see that our artist is added automatically. This makes it really easy for if you're trying to manage data in your application outside of Firebase, or let's say you want to share it with some collaborators. This makes it so that all admins have access to this root level adjusting. So if we go over here, we can actually copy all the documents that are currently on the page to the clipboard if you're wanting to save it offline, or we can read them. So if you want to insert them, this could be a way to do data import and export. And we have this edit button. Here, where some of the magic happens. We have this collection group, and we have some top level fields like what kind of name it is. The description is optional. Like I said, it's used for the comments. And we have this bundle option. If it's true, it'll get added to the bundle that gets uploaded to Firebase storage, making it really easy to access this data. This is good for data that doesn't change often. And by default, you always get a bundle because the schema is included as part of that. You may want to include the schema when you're with your app so that when the first time the user opens the app, if they're offline, they can still have access to data and to create local data. So cool. Let's just go through like creating a field. When you can delete and edit fields and add ones, but you can't reorder them because it doesn't really make sense here since they're kind of unordered keys. We can give a new field, let's call it like social. And here we have these types that I was talking about before. If we want to do a document type, we'll actually get a drop down with all the other schemas that we can choose from. But otherwise, we can choose the content that makes sense here. Note that not every type gets supported in GraphQL. For example, arrays and maps and dynamic can't be generated because we don't have the type information for those. But everything else will ultimately resolve to something. I'm also using Freezed to generate these classes, which I really liked because I was able to do a sealed union here. For example, like string could take a max length, but then int takes no property. So just a shout out there. I really liked it. So we can use a string type for this. And then if we edit this name and this schema already exists, it'll add name to the previous values. So cool. I'm going to hit save. And if you note, nothing gets added. But if we go back, we should see the social column, which is not required by default because we didn't set it up that way. Awesome. So now that we have all this set up, what does generating the client look like? Well, let's go ahead and jump into the code. I have a couple commands. I wrote a Flutter scripts package that just lets me define scripts in my pubspec YAML. And so I have a couple scripts here. Here we're saying run the CLI, which is just a CLI version of these classes, and set the working directory to example. And we want GraphQL, we want a REST API, and we want the client. We also have some helpful commands like starting the emulators. So what happens when you run it? Well, here is an example of the functions that get generated, which I'm pretty excited about, and it works really well. This whole file is generated from your schema. So it can check to see if you're choosing REST API or not. So here we have some get, post, put, and delete methods, which will handle the collection accordingly. One thing I really liked about Pocketbase there was that it had all this. It had a rich API out of the box, so that like if you're just trying to build something quickly, you can just throw it on REST, and this would allow you to work with your collections even without a Firebase SDK client. Of course, you still need to be logged in. And here we're defining the collections that we set. Here is our triggers. So if you notice, we have a trigger on delete field, and let's look at the artist, for example. When the artist is deleted, we know that the album is associated with that, so we can make sure to add it to the batch and delete it. Same for song and album. So it's like a really nice way to kind of have that relational database feel to a NoSQL database. Here is where we're doing the bundles. We have our upload bundle, which will take by default just our schema and any other collections that have been added to it. So for example, we have album, and then it'll get added to our default bucket with collection bundle, and then also we will be able to download it. I also have an option for caching. This is used in conjunction with our Firebase JSON, where we can use Firebase hosting to actually serve our bundle through a CDN. So that's what this smaxage is for. So here is our GraphQL client. Note that we have this really rich type information. This is all coming from our generated schemas. We have album, album track, artist, and song, and then a note of our queries. I'm still working on the mutation, but I feel like this is pretty good to get started. So here's our resolvers. We have all the different top level ones, but we also have the nested ones. So, you know, an album is pointing to artist ID, but we actually can point directly to that artist since it is a graph. And so we can show that here. And of course, we create the server and the GraphQL endpoint. And looking at our generated client, we have a client that extends Firestore client. We get a list of collections used to iterate over all of them and updating them as needed. But we can see that we have our description that we put into our schema. We're defining them here, so they're strongly typed. We also have a schema.json that is generated at the root level as well. Currently, you have to do the copy schema to create this locally for any of these CLIs to work. And then let's also look at these generated collections. We have an album, for example. It hard codes the JSON in here, but you may be thinking like, well, doesn't that defeat the purpose of this update? But this collection is actually stored inside this class, and this class can update that collection over time. Since we're storing this in the database and also from a Firestore record, we'll be able to gather updates as they come. And that's why in your UI, you'll be accessing things like song ID directly or album ID. And notice I don't have the GraphQL nested collections yet, but I'm sure that'll come soon. But we're accessing through this overloading the operator for array index accessing. And this is where some of the magic happens. This is where in our UI, we can query the collection. And here we have a hard-coded name, and we're referencing it right there. So that's like a really cool way that in your code, you want to write with these strongly typed classes. But it's not as rigid as a full JSON serialized class that can't update over time. This way we can have updates to our application and our data without having to deploy updates to our app every single time in lockstep. So just wanted to show that. And we still get all the benefits of offline caching and be able to store it in their database and reading it, but just a little bit more of that safety and flexibility. And here in our initialization of Firebase. We're using emulators here. Of course, you don't have to do this, but it's just a nice way to show how this all working. If you're wanting to generate your own, or if you're trying to run this example, make sure to create a Firebase RC, and you're going to put in whatever project you have for Firebase. By default, I'm just building it here locally, so you can have something in production. It's a lot faster to work with the emulator offline, so you can make big changes and see if it's going to work for your application. And we just have some simple commands on here how to get started. But yeah, so also want to kind of talk through the logic of like how all this kind of works together. So I have I'm using Mustache for the generators. This allows me to, for example, in the functions generator, I can have options passed in, knowing which type of imports to use, and to be able to generate this from some JSON results. Same for the collections. We can extend the client and do all this. This is itself a local package, so you could just import it from Git, for example, and use it. But yeah, so we're doing all the information here to serialize it. And like I said earlier, one nice thing about this serialization is I'm using freezed. So you could have like this sealed union type. I started off with an enum, but quickly realized there was a lot of issues when it came to like I needed extra parameters, but only for certain fields. And it was a great fit. Here I'm just parsing the type and returning an iteration of them. This is used for the generators. But yeah, I really like it. I kind of came up with this a couple days ago and been starting to just mull over like all the different ways in which I can use this. But I hope this is helpful. Like I said, I'm currently running this example, and this is happening live. Yeah, and so works pretty good. Very curious about your thoughts here, and as always, feel free to reach out. All right, I think that does it. I'm going to put the link in the description, and you can find out more about this project. Feel free to provide me feedback, but yeah, if there's any questions, reach out to me on Twitter. All right, good to see y'all.